Okay, so identify the effect of increasing acidity on the solubility of the given compounds. So from, just to start off, from Le Chatelier's principle, we're going to expect that increasing acidity is going to increase our solubility. So increasing acidity will increase solubility for basic solutions. And we should be able to verify this anyway. So if we look here, so for zinc sulfide, which has no such line, zinc sulfide, which is going to dissolve into zinc 2 plus S 2 minus. Zinc, so the first two columns in the periodic table, right? So zinc 2 plus is one of the alkali earth metals. Both of the first two columns form strong bases with OH. The reason why I'm mentioning this is because if we combine this with water, we're going to get zinc hydroxide plus H plus, and so this would be zinc acting as a acid, so accepting OH minus. But that's a strong base, so this does not happen, and it only goes that way. So this reaction doesn't go. S2 minus plus 2 water gives us maybe I'll actually just leave it like this, 1 water, and make it go to HS minus plus OH minus. In this case, we actually have a weak base. So this guy's a weak base, meaning that this is also a weak acid. And so this reaction should go. And so we would have a weakly basic solution. And so in this case, if we add H3O plus ions, then they will combine with our OH minus to give us water, eating up our OH minus and shifting the solution more to this side, which will in the end shift more to this side because we're eating up our S2 minus, and so then this will increase the solubility. So we'll get increased solubility here with increased acidity. Okay, and again, just to tie back, we get increased solubility with increased acidity for a solution that's weakly basic, because this is a basic salt. Okay, so then if we go on to the next one, so MgCO3, so this is going to dissolve into Mg2 plus CO3 2 minus. Again, this is an alkali earth metal, so that's going to form a strong base and with water. So if we combine this with 2 waters, we would get MgOH2 plus 2H plus, but that's a strong base, meaning it doesn't go back and forth, it just goes one direction. And since that one direction is back, that means we aren't going anywhere near that. so that it's going to just stay in solution like this, while CO3 2 minus, if we combine it with water, we will get HCO3 minus plus OH minus. This is a weak base. And so this will go. So we're going to get a basic solution, and so we're going to get increased solubility with increased acidity. Okay, so we're going to get for a basic salt, increasing the acidity will increase the solubility. Barium hydroxide. Well, barium hydroxide is a base, so we're going to get barium 2 plus 2 OH minus, and in this case we've already got our OH minus. We don't even need to consider whether it will prepare OH minus, so we're just straight up going to get H3O plus OH minus going to H2O, which is going to eat up our OH minus and increase our solubility. So this is basic, so increased solubility for increased acidity. Okay, and then Ca3 PO4 2. So this is going to dissolve into 3 calcium 2 plus 2 PO4 3 minus. Yep. Again, we have a alkali earth metal, so the reaction with water, as we can guess, is not going to go. Right, so this here is a strong base, which means this doesn't go, and it just goes backwards. So we only have our reactants, whereas PO4 3 minus combines with water to give us HPO4 2 minus plus OH minus. Excuse me, which is a weak acid, and so we're going to get OH minus in solution, so this is a basic salt, and so increasing acidity will lead to increased solubility. Okay, so at this point it's appearing like increasing acidity just always increases solubility. Now for the next one, this is going to dissolve into nickel 2 plus 2 Br minus. So in this case, we have nickel 2 plus, and so again, alkali earth metal. So NiOH2, but this is a strong base. Meaning it only goes that way. So we get nothing happening there. And then if we combine Br minus with water, then we get HBr plus OH minus. And in this case, this is a strong acid, meaning it doesn't go that way. And so everything just stays in solution here. And so this is actually a neutral solution, as we have, as both species are either the conjugate acid or conjugate base of a strong base or a strong acid. And so because it's a neutral solution or a neutral salt, increasing acidity will have no effect on solubility. And we can verify this because further anyway by saying that H3O, if we add H3O plus to say Br minus, then again we would want to form HBr plus H2O, but as that's a strong acid, it's not going to go. So H2O plus, adding H2O plus to the solution just had nothing to react to it. So we increasing the acidity will do nothing to the solubility. And so for then for copper iodide, we have a similar kind of thing here, right? So copper 2 plus I minus. Copper 2 plus is again an alkali earth, or no, it's not, sorry. Copper 2 plus, neither was nickel 2 plus, sorry. Both of these are D block metals. So copper 2 plus, but it should still form a strong base, or at most an acidic solution. Yeah, okay, so then 2 H plus, so this guy is a strong base. Which means that doesn't go. And then I minus plus H2O. And it's full of a whole bunch of mistakes here, so this must be copper plus, not copper 2 plus. Which means this would be just copper plus. And it's actually just a single OH, and I don't need these twos. Sorry about that. So again, H2O with I minus. It's going to give us HI plus OH minus. That's a strong acid though. So it's not going to go both ways. It's just going to go backwards. And so this is a neutral salt, which means that increasing our acidity will have no effect on solubility. Okay, so basically, if we look, our first four, increasing our acidity would increase our solubility, but for the latter two, increasing our acidity should have no effect. Okay, so they mentioned that Le Chatelier's principle states that pH should affect, but they don't say what effect. So if it's a basic solution, it will increase, whereas neutral or acidic, it shouldn't have an effect, or it should have a negative effect for acidity. Okay, so for the first one, increased solubility for increased acidity looks good. Increased solubility for increased acidity for the second one. Same for the third. Same for the fourth. But then for the fourth or fifth, they still said increased, which is incorrect. So for these two species, adding H plus will do nothing because we don't want to form HBr and we don't want to form HI. Or those two species will actually just go backwards into solution. So 1 to 4 are increased solubility. bases are no effect. Strong acids. So I'm going to say it's incorrect.